Well, in the previous division, we looked at long division, dividing one polynomial by another polynomial. Well, now we're going to look at a simpler way to do it. It doesn't always work. Well, it'll always give you the right answer, but there's a certain restriction. This is called synthetic division. It's only valid when the divisor has this form, x minus some constant. The constant c could be any real number you want. So in other words, if the coefficient of the x is something other than 1, we would have to do something else to make this work. So you want to get it to where you have a polynomial divided by x plus or minus a number. So it can't be x squared, it's got to be divided by x plus or minus c. Since c can be any real number, it could be, c could also be negative, as we're going to see in this case. We're going to look at the recipe. At the same time, we're doing an example. We're going to divide this polynomial, a third degree polynomial, by x plus 2. So what is our value of c? If we're dividing by x plus 2, c would be negative 2, because it would be like x minus a negative 2. All right, so what we do, I'm going to start it down here. We write c in what they call the cup. Just make a little shape. It can be any way, anything you want. Put negative 2 in a little box like that, or a half box. And then we copy the leading coefficients, or I'm sorry, we copy all of the coefficients of this polynomial, but it must be in correct order. And not only that, every single place from the x cubed place to the x squared place, which notice it doesn't even show up here, x squared. So we're going to have to put a 0 in for the placeholder, then down to the x and into the constant. So it's going to be 5, then 0, then 6, and then 8. And you leave a little bit of room for one more row, and then you write a horizontal line segment like that. All right. The first thing you do is really easy. Okay, so let's review what we've got here. Negative 2 is in the cup because we're dividing our polynomial by x plus 2. So our value of c would really be a negative 2. So basically, just take the opposite of whatever you see here. If it's a negative 2, you put 2 here. If it's a positive 2, you put negative 2 here. And then this is the coefficients of our dividend, our polynomial here. It looks like it's 5, 6, 8, but notice that the x squared term is missing, so we had to put a 0 in there. Okay, that's the setup. We'll take the leading coefficient, just write it. Just go straight down and write it below the line. Now, we're going to multiply this 5 here by the number in the cup, giving me a negative 10, and I'm going to write it right here. And then add this column. 0 and negative 10 is negative 10. Then we just repeat that till we're done. Take this value and multiply it by the cup, the number in the cup, and we get a positive 20, and add the column. And we do that one more time and we're done. Negative 2 times 26 is negative 52. Add this and we'd get what? Negative 44. This number is the remainder, the negative 44. This portion tells us what the quotient is, given that this is the remainder. It's going to be whatever we started with. What was the degree of the polynomial that we started with? 5x cubed, so it's going to go down by 1 because we're dividing by x. So this is going to be 5x squared minus 10x, because of the minus 10, plus a 26, and then we're going to add the remainder as, I'll put plus, and then negative 44 on top, and x plus 2 on the bottom. That is our quotient, our result of dividing this polynomial by x plus 2. Okay, let's do one more example and we'll finish this video. All right, once again, we're getting a polynomial that's not written in standard form, decreasing values of the exponent of x. So, let's see, and I even wrote this. This one's written backwards, 5 plus x. You know, I'd rather see it as x plus 5, and that tells us that c is negative 5. That number's going to go into the cup. Okay, so we need to make sure we get this in the right order. I'm going to circle them every time we use them. This is a 4th degree polynomial. Well, let me put negative 5 in the cup first. Okay, and now it's going to be a 1. And then the next term would be the x to the 3rd term, so I'm going to put an 11. And then we've got an x squared term, which means I put 41. We have an x term, which means I put 61. And then the constant term, which is 30. All right, so then we bring the 1 down for starting. And now we just do negative 5 times 1, which is negative 5. And we add that column, which gives us a 6. Negative 5 times 6 is negative 30. Add that column, and we get an 11. Negative 5 times 11 is negative 55. And if we add these, we'd get a 6. And negative 5 times 6 is negative 30. If we add that, we get 0. This is what we like, because this is frequently going to be the case when we do our divisions. The remainder is 0. That means that this polynomial goes evenly into this one with no remainder whatsoever. And the result is, I'll just write it down here. Here we've got the original polynomial divided by 5 plus x, or x plus 5. And this is going to be the coefficients of our result. Since we started with an x to the 4th polynomial, and we're dividing it by something that has 1x in it, it's going to go 1 less than that. This is going to be the x to the 3rd coefficient. So x to the 3rd, 1x to the 3rd, plus 6x squared plus 11x plus 6 is the result. All right, so as I've mentioned before, notice that the degree of the remainder, well, if there is a remainder, there was no remainder here. But it is, notice the degree of the remainder is obviously less than the degree of the divisor. Maybe I should write less than the degree of the divisor. In this case, there was no remainder. Going back up to this one, the degree of the remainder, here it's x squared. I'm sorry, the degree of the quotient is x squared. The degree of the divisor is what? The degree of the divisor is always degree 1 when we're doing synthetic division. Remember that? We have to have simply x plus or minus a number. So for us, that means the remainder is always going to be degree 0, which means just a constant. Every time we do synthetic division, it's going to be a constant remainder. So we could say constant remainder. We can just say it's always just a number, just a real number. It'll have nothing to do with x. All right, we'll continue this in the next video.